Hi, my name is Kiat, and today I am going to present a journal titled Friction-Induced Lubricating Nanocoatings of Mentioned Thermotropic Liquid Crystalline Polymer by Fanglin Xu, Yuanshi Xin, and Tongsen Li. In the abstract of the journal, they actually show that the polymeric lubrication nowadays is applied widely in tribological applications because of the low shear strength and the low coefficient of friction. However, polymeric lubrication has limitations such as high wear rate in tribological applications. So sometimes to decrease the wear rate, reinforcing fillers are required to control the wear rate, but such action will increase the coefficient of friction. So the authors has actually proposed that liquid crystalline polymer, LCP, is able to simultaneously lower the wear volume and coefficient of friction when introduced to polyvilidene fluoride, PVDF, as lubricant. So the research is done to propose a novel lubrication mechanism of LCP and to provide support for further tribological application in polymeric system. The research is split into 3 phases. The first one will be the sample preparation, second will be the friction procedure, and the third one will be the characterization. First, in sample preparation, 90% weightage of PVDF and 10% of LCP is blended and undergo melt mixing at 290 degrees Celsius, 70 RPM for 10 minutes. After that, the blend is quenched in ice water before getting hot pressing into disc at 2000 degrees Celsius, 100 megapascal for 5 minutes. After pressing into disc, the disc is being cooled at 20 degrees Celsius and 10 megapascal. The disc and the sample is pre-dried at 90 degrees Celsius 12 hours prior to the experiment. So the friction procedure is done by using the tribometer, where the load will be applied onto the sample and sliding left and right on the sample for maximum 30 minutes. While the characterizations are carried out in field approach to show the wear resistance and coefficient of friction under different periods of times, the morphology of the surface will be undergo the polarized light optical microscope. Raman spectrometry will be displayed by Explorer spectrometer, and the hardness is tested by using the ultra nano indentation tester. So for now, I'm going to present the results of the research. For corresponding wear volume and coefficient of friction, for 90% PVDF and 10% LCP, we can split into 3 phases. The first one will be the running in phases. As in the running in phases, because of the initial contact between the surface, the wear volume is actually increasing more significantly than the second phase and the third phase. After 4 minutes and a half, we actually get into the transition phase. As a transition phase, because of the regular and smooth sliding motion between the two contacting surface, the wear volume of the sample is getting lower. After 15 minutes, we get into the steady state phase, where the wear volume is actually increasing very slowly compared to the first phase and the second phase, which means that actually the LCP nanoparticles is actually helping to improve the sliding motion between this contacting surface. Comparing to the right hand side, the neat PVDF is actually having a high wear volume throughout the experiment. where you can see as the first phase, same as the running in phase, the wear volume of the neat PVDF is actually over 2 millimeter cube. And after that, they will get into maybe steady state, but actually the wear rate is still higher than the one in the sample. The coefficient of friction of the 90% PVDF and 10% LCP is actually around 0.025 throughout the experiment. However, for the neat PVDF, coefficient of friction is actually increased until 0.5 till the end of the experiment. So for the morphology of the experiment, we actually did it under the polarized light optical microscope, so-called POM. For the 9 figures taken, we can see there are 3 rows. The first row is the running phase, second row is the transition phase, and the third row is the steady state. So for the running in phase, we can see for the first minute, we have actually the high initial wear rate and rough surface of the sample. So you can see there is a very big dark spot on the figure. And for the 10th minute at the transition state, because of the continuous sliding motion between the contacting surface, we can see there is a smearing effect of the LCP nanoparticles throughout the experiment and throughout the area. So by the Raman spectrometry, actually the things that worth to be noticed is actually for the 1600 per centimeter Raman shift. So 1600 is actually referring to the 1,4-param substitute benzene ring, which is actually the LCP nanoparticles in the sample. As you can see throughout the experiment, there is a very significant increment of LCP contents because of the continuous sliding effect in the steady state. As you can see, the peak at the 15th minute and 20th minute is actually higher than the others. So for the nano indentation test, which is to measure the hardness of the sample, we actually the authors actually carry out for 0, 1, 1st, 2nd, 3rd, 5th, 10, 12, 15, 20th and 30th minutes of the sample. As you can see, although the hardness of the sample is actually decreasing at the beginning of the experiment, but after 12 minutes, the hardness of the sample is actually better than the initial one of the sample. So for the limitation of the research, actually the authors stated that the phenomena, which is the positive phenomena, is actually maintained until the 30th minutes. After the 30th minute, the wear volume is actually start to strike up high because the LCP nanoparticles is actually starting to wear off. So results to 120 minutes, you can see the wear volume is actually started to hit until 1.5 millimeter cube. So the endurance of the LCP nanoparticles mixtures has to be improved more later. In my opinion, the authors should provide observations on morphology of samples after 30 minutes too, because we need to understand why the wear volume of the samples starting to increase after 30 minutes. Other than that, the authors should conduct research on different ratio of PVDF LCD blend, because in the research that mentioned, there is only one ratio, which is 90% PVDF and 10% LCD blend is used. So we should note that how the different ratio of PVDF and LCD blend will affect the results throughout the experiment. So that's all for my presentation. Thank you very much.